2030, all of its systems will eventually fail, and the probe will be left all alone in the chilling recesses of space. As a rule, it's potentially habitable planets with favorable conditions and a moderate climate that especially catch one's attention among the great diversity of other worlds out there, or else, on the contrary, extremely dangerous objects stand out among others. Still, there is yet a third category. It's anomalous celestial objects manifesting unusual behavior which is barely scientifically accountable. Objects like that challenge our knowledge and deserve special attention. This is exactly the kind of world we'll be looking at now. The year 2009. The environs of the Kepler 413 system. An unknown object passes between our planet and a distant star, briefly reducing its luminosity. Astronomers take this event to be a standard exoplanet transit and announce the discovery of a new celestial body. High-precision calculations even make it possible to determine its parameters. The planet turns out to be a cool giant, with a mass of about 25 times that of the Earth and a radius of about 40% that of Jupiter. However, 180 days later, another expected transit never occurred. The planet, so clearly visible in the old data, seemed to have vanished without a trace. A dark spot in the photosphere of the star, or a giant dust cloud moving in its vicinity, would have accounted for the mysterious phenomenon. But these hypotheses were dispelled when 800 days later the mysterious object reappeared just as suddenly as it had vanished. The hypothetical planet eclipsed the disk of its parent star 5 times before disappearing again. Still, the key to the riddle had been found. It turned out that Kepler 413b has a highly unusual orbit. The celestial body is located near a binary star and is 0.36 astronomical units from the system's common mass center. Its trajectory is constantly affected by gravitational perturbations, and the change in gravitation of 2 nearby stars shifts the orbital plane considerably, causing cyclic oscillations. When the deviation reaches its maximum, the object leaves the line of vision and then returns to it. Calculations show that Kepler 413b's orbit oscillates with a periodicity of about 11 years, deviating 2.5 degrees in each direction from its average value. The planet's own axis of rotation also changes its position significantly, with a maximum angle of inclination of up to 30 degrees. Combined with a notable eccentricity of the orbit and its periodic shift, the climatic conditions on the surface change in a bizarre way. The region that receives the most light from the parent star is constantly shifting from the equator to the poles and back, which leads to dramatic variations in temperature. It is likely that this process generates huge planetary-scale hurricanes, which can be larger than the Great Red Spot of Jupiter. Air currents can carry ice clouds at several kilometers per second, gradually becoming unstable and dispersing. Meanwhile, the collision and deformation of vortices is capable of causing tremendous atmospheric emissions that have the power to overcome the planet's gravity and reach outer space. According to calculations, they will hang a while up there before gravitational forces pull them back down. All these incredible phenomena make the planet a rather harsh place. However, it may seem like a tranquil, serene island in comparison to the following world. "190 light-years from Earth. The environs of the HD 10606 system. This yellow dwarf, surprisingly similar in parameters to the Sun, is orbited by a planet with a highly variable climate. It whizzes towards its parent star as rapidly as a giant comet, burning itself in the hot rays of its corona, only to retreat to the periphery of the system. The object is a gas giant with a mass 4 times that of Jupiter and a radius slightly different from that of Jupiter. At the furthest point in its